Hi, this is Majid. I would like to compare the results of RCWA and FDTD. So this is our structure. Our structure, the substrate of our structure is SiO2, as you see here. The material is SiO2, and the waveguide is silicon. So our waveguide is periodic in the x direction. So this is x direction, this is y direction. So I would like to simulate the transmission and reflection for this periodic structure based on FDTD and RCWA. For the FDTD, so in the next step, we need a solver, so you can insert the solver from this region. So add FDTD. So I already added to the simulation. So this is our FDTD simulation. So if you look at in the y direction is the PML and x direction is periodic. So let's so as you see here, our FDT is a 2D, and so in the boundary condition, so just x min as a periodic and y min and y max as a PML. So we would like to simulate based on FDTD first. So in the next step, we need a source. You can insert the source from here, plane wave. So our source is plane wave. So as you see here, source type plane wave, and the plane wave type is Bloch periodic. So we want to inject the light from the y direction as in a backward. So and the frequency we are interested to frequency of 1.1 to 1.9. So in the next step we need some monitors. So I already had the monitors here. So we have a T. So maybe it's better just rename it to R, and then this is T. So this is R. This is R, and this is T. So it's a transmission, and this is for reflection. So regarding to the setting of this monitor, so if you go to the edit object and go to geometry, it's 2D Y normal for the transmission. For the reflection and transmission is the same, 2D Y normal. And also we have a monitor that simulate the Z normal, 2D Z normal, as you see here, and we don't need a movie, so I disable the movie. So now I will run the simulation based on FDT. In this step we need to see the results. So if I go to the R, visualize, and then select T, and if I go to the T and add to visualize, and then select T, and then change this one to minus real. So this is the simulation of FDTD. So as you see here, so the blue is reflection and the green is transmission. So now we want to add the RCWA. So I will go to the layout mode, and then I can add the RCWA from here. So at the RCWA, let's look at the setting of FDTD. So if you go to the geometry, you see that the x band is 0.5 and y band is 0.75. We can select the same setting for the RCWA. So the geometry 0, so 0.5, like 0, 0.75, and also before we can select the propagation axis as y, so we are interested 2D Z normal. So we select the interface reference position, and we are interested just for silicon, so let's select the mean and marks of silicon. So I select, I'm interested to this two boundary, minimum and maximum of silicon. So let's K vector domain to change to the rectangular, and maybe 51 is enough for the material. For the excitation we can select 1.1 to 1.9 for instance, like we can select 101 points. So let's do the simulation. If I click the run, we see two bottom, so I will select run RCWA. So now I select total energy and then click on visualize, add to visualize one. So you can see that there is a TP and TS. So I removed the polarization. So just I'm interested to the TS and RS. As you see here, so let's look at the results. So this is a T, like as a green, and is a T as a magenta. So we can change the color to black. So as you see here, the results for both RCWA and FDTD almost same. Thank you.